Hello, and what I'd like to do today is talk a little bit about the solar system. I'm not exactly sure if I'm going to do the whole presentation all at once because this may end up being kind of long. But the solar system basically has been our household, our home, for about the last 4.6 billion years. So it's 4.6 billion years old. It actually has a lot of members in it. Some of them you can see very easily. Like no problem with the Sun. You can see Mercury, Venus, Earth, Mars, Jupiter, Saturn, and then the rest of these you need some help. Telescopes to see Uranus, Neptune, Ceres, which is the largest of the asteroids, Pluto, and any of the other what are called dwarf planets. Things to always consider when you view an astronomical picture is that scale is probably not correct. Now this picture actually does have something in scale. Can you tell what it is? Do you think actually the planets are this close to the Sun or this close together? No, it doesn't. They're not showing you distance scale, but they are showing you relative size. If this was going to be the Sun, Mercury would be this little speck, and Venus would be a little bigger, and Earth would be just a tad bigger than that. Mars would be smaller, and you can see these as they go along. Ceres, which is right there, relatively small. Pluto is there, and then the rest of the dwarf planets, some a little bit bigger than that, most of them much smaller. So something is always out of scale. If they give you distance, they probably won't show you the right size. If they give you size, they probably won't show you the right distance. They do have the right coloring in here that sometimes is out of scale as well. But the problem is, when we actually have this, if we go back 13.75 billion years ago, BYA as opposed to BYO, the Big Bang only produced hydrogen and helium. So basically what happened is we had, with this, we had a whole bunch of hydrogen and helium. Can't see the size of the pen. We had hydrogen and helium produced. How did we get things like silicon and oxygen to make most of the Earth, or to make methane, which is most of the atmosphere of these two last planets? We needed to actually the help of some other things. So the Big Bang, as it coalesced, actually started producing galaxies. This is National Galactic Catalog, NGC 1300, a beautiful barred spiral galaxy, which we'll talk about relatively soon. And inside here we have a bunch of stars, some of them really massive stars that go through their life very quickly. When we talk about lives of stars producing supernova, this is a supernova, the Crab Nebula, and it's actually out there, and they contain these, and these things actually produce all the elements that create us. So we don't think we're a first generation star or solar system. We're probably either a second, a third, or a fourth generation. We need a lot of help to create some of the elements that we find, most of the elements we find in the planets, as well as some of the elements we find in the Sun. Sun is capable of probably going all the way to iron, but it's not capable to go to gold and silver, things that we do find in our solar system. Okay, I put this gumball machine here to actually ask you which of these planets would actually be probably good-sized gumballs, actually even the star. Which of these members of the solar system would actually be good-sized gumballs, which probably are like that size, or maybe a little bigger, a little smaller. And these guys are probably too big. If they actually put that size gumball in there, probably have to make this thing a little larger, and this would probably cost you a couple bucks. But if you really wanted a quarter or 50 cents, I don't know what a gumball actually costs today, you're probably looking at these guys, primarily these guys. Okay, let's talk about the members of the solar system. Sun we'll talk about later. The planets, they come in basically two flavors. We have these planets right here. These are called the terrestrial planets, and what terrestrial planets mean is that you can stand on them. You can jump up and down on them. You can build on them. You can even make swimming pools on them, although this would not be the planet you made a swimming pool. Venus is the warmest planet. Even though it's not the warmest planet away, its atmosphere is so thick that whatever heat comes in it from the sun gets trapped. It's a greenhouse gone wild. We talk about our global climate change. Some of the places getting a little older than that. A little warmer than what we normally get. It's not going to get anywhere as warm. I call Venus the triple kill planet. First off, the atmosphere full of hydrochloric acid. Second thing, the planet's temperature, 900 degrees Fahrenheit. That's hot enough to melt lead. And third thing, the atmospheric pressure is 90 times what we would experience. So if you could actually survive this one, this would crush you, probably a little bigger than a basketball, monk and eye ball, if you know what that is. Okay, so triple kill planet. Earth is a very unique planet, only one that actually has water in all three phases, is able to support life, is a certain distance from the sun, has a beautiful atmosphere, has mostly water on the surface. Mars, the god of war, fourth planet out, has a very red, iron-rich surface. Does have a thin atmosphere, but not really thick enough for us to survive. Does have liquid water. Does have solid water on it. Probably has had liquid water on the surface, based on discoveries that we've made. May actually have liquid water underneath. Mercury, very much like the moon. In fact, it looks even more like the moon because of the cratered surface. Much more cratered than our moon. It's a little bigger than our moon. It is the closest planet. It is the planet that actually has the shortest year. We talked about the speeds of orbits, and we'll talk about that down here a little farther. But these are all called terrestrial planets. They're smaller, they're rocky, they have very few natural satellites, and they all tend to be closer to the sun. And then when they were closer to the sun, they were there because hot temperatures. The only things that could really turn solid would have been the metals. Then over here we have what are called the Jovian planets. These guys make up the Jovian planets. And things different about the Jovian planets is that they're made out of gases. If you landed on this planet, you would be falling through, and would eventually, probably like right in this area, green metallic hydrogen, maybe a little higher than that, like maybe in this area, you'd find yourself floating, but you'd be a couple thousand miles inside the surface, or what actually looks like the surface to us, the atmosphere of Jupiter. Okay, so size-wise, these are larger. They have more satellites. They're gaseous. That's the biggest difference between Jovian and terrestrial. Jovian planet Jupiter, the largest one, which is actually called Jove, the god of gods, Zeus. Jovian planets are actually named after this Jove. It is a very large planet, has a lot of satellites. I think Uranus actually has the most, but I'm not really up on the number of satellites because it changes so often and what makes up a satellite. It is the largest one. It has 3 Jovian moons, which Galileo actually discovered with his telescope. And that actually helped prove the whole idea of the geocentric universe going out and the heliocentric universe coming in. It does have beautiful bands. It has the giant red spot. It's a hurricane-like storm. It's got quite a few other ones. But this one we never saw form, and we've actually seen it since Galileo. So, it's hundreds of years old. If that thing was actually on the Earth, if I can scroll up here for a second, imagine this giant red spot right there on this planet right there. It would actually be bigger than our atmosphere and would do a really good job of pulverizing anything that sticks up. Saturn, and it does have a really faint ring. In fact, all these planets have rings, so I'm going to put that up there too. None of these planets have rings. So these are smaller, few satellites. They're made of hard surfaces, and they have no rings. This is truly the ring planet. If you start looking at some of the things in here, again, this is where we actually start saying we don't know how big the satellites really should be, because these rocks, some of these rocks and ice crystals that make up this layer. And if you ever watched, what's the name of that robot movie? It'll come to me maybe. Where he's actually flying out looking for his lost love that's already flown away. He goes through here and he touches it, and you can see these things. It's not a solid ring. You can't stand on it. In fact, if you were standing right here, if you could stand on the ring of Saturn, you'd find out that the gravity of Saturn would pull you in, and you just go and then end up inside just like you do here. Uranus is a very strange planet. If you take a look at Uranus is right here. It almost goes through space like a barrel. Its north and south poles are located over here. So it actually has very, very, very distinct seasons. I think it takes 80 years. We'll see that. Let's actually go down and see this. 84 years to go around the sun. So basically what happens is it gets to see the sun for half of that period, like 42 years, and then as the other hemisphere sees the sun, it's in total darkness. So it has a very long year and very long darkness. Does have some really wicked moons. One of the moons actually looks like it's being, and the name begins with an M, and it's slipped my mind. One of the moons actually looks like it's had some really hard collisions with other things, a very hard life. Neptune, both these planets made out of methane. Neptune probably the prettiest, in my opinion, prettiest of all the planets. It is just a beautiful blue. It's even more blue than our oceans. Does have a giant blue spot. Giant hurricane going around it. Does have a whole lot of satellites, but all these guys have a really small central rocky core with a whole bunch of gaseous hydrogen. They don't have methane on here, but methane, which is NH4. These are very high in methane. Methane would actually is a really good fuel, but why don't Uranus and Neptune explode? They're missing O2. They've got a fuel, they have lightning, so they have sparks. They're missing the oxygen for the fire. Okay, if you take a look at the planets, Jupiter's almost straight up and down. Saturn's tilted pretty well, so almost no seasons. Does have seasons. We already talked about Uranus, wacky seasons. Does have seasons, and we can see Pluto's wacko too. One of the reasons why in 2003 Pluto got denied major planet status, and now is a dwarf. Mercury, pretty much straight up and down. Venus actually rotates the wrong direction. What we think happened to Venus is it had a really bad day and somehow got knocked upside down. We talked about Earth and seasons, and we can see Mars has just about the same tilt, so the same daytime, a little shorter, but the same daytime. So it would be very easy to move to this planet and be happy as a clam if we can change a couple things like make a thicker atmosphere, put some oxygen up there, liquid water, and some other things. Temperatures on the planets. If you take a look at it, here's where water boils. The first two planets, Mercury and Venus, not real good. Remember the triple kill planet is up there and 900 degrees Fahrenheit. really easy to boil water, and you can see it's about 475 in terms of Celsius. Earth, right at where water freezes. Mars, deeper than that. And here we actually get other gases to freeze. None of the planets get to minus 273 degrees, which is absolute zero, but these guys are going to be bone-chilling cold. Average day on each of the planets. You can see Mercury has a long day. Venus actually has a longer day. Venus has a longer day than its year. You can see right here its revolution, which is the year, 224.68, and its period of rotation, which is the day, is 243. It's the only planet has, you'd actually be more years old than you'd be days old. And if you think about that on our planet, pretty wild. You can see the year, just a little bit different than ours from Mars. Jupiter, days, a little bit longer. Jupiter, about 10 hours, about 12 hours, sitting at around 13, 14, 15, 20 hours. And then Pluto again, wacko Pluto. I really wish Pluto would have stayed a planet because it's made a planet, but I can see why they demoted it. Orbital velocity, closer you are to the sun, the faster you're moving, right around 30 miles per second. Earth is right around 30 kilometers, because these are miles, but you can see that change, and it is a nice perfect curve. Whoops. Because that's the way it should be. The farther you are from the sun, the slower you have to move. This is from Enchanted Learning site, and you can see it gives you information, gives you the name of the planet and whether it's a dwarf planet, like there. Distance from the sun gives it to you in AUs, gives it to you in miles, gives it to you in millions of kilometers too. Gives you revolution, which is how long it takes to go around the sun in Earth days, in Earth years. Gives you the period of rotation, how long it orbits on its axis, and you can see long orbiting on the axis there, longer, 24, 24.6, almost 10, but a little more, 18, almost 20, and then 6.39. Mass, you can see the most massive planet is this one right here. The most massive planet is going to be this one, times 10 to the 27th. But the most dense planet is this one. So we got the most massive planet here. We've got the most dense planet. They don't tell you the density on this one. And this one. They're going to tell you density in this one. Yeah, they'll tell you density down here, so I'll talk about that. Longest day. Longest distance. Longest year. To get rid of this one. Longest year, 248. Longest day, 243. Most mass. Diameter. Average size, apparent size from Earth. Arc second, if you can hold your finger up at arm's length. There's your fingernail. Here's one little knuckle. There's the other little knuckle. And here's your rest of your hand. If you hold up your index finger at arm's length, that's about 1 arc second of space. And what that means is 360 degrees divided up so you can get a degree. Divide this one up into 60 units. These would be called arc minutes. Take one of those arc minutes, divide that up into 60 units. Those would be called arc seconds. So you have 3,600 arc seconds in this 360 degree. Your finger at arm's length is about one of these. And the sun would be about half of that. Okay, so Mercury would be somewhere between 5 and 13 arc seconds. We can see those. We won't really talk about that. Temperature, you can see it actually has very high daytime temperature, very low nighttime temperature, pretty much the same temperature all around, hot as Hades. We can actually go from a relatively warm daytime temperature to a relatively cold, and these are going to be in Kelvin. And then you can see all the way down to the coldest, and there's the warmest. Number of moons, plus 18. It's probably more like 40. I think all these numbers are probably larger by now. This is out of your Earth Science reference tables, and it does have the sun in there. Equatorial diameter really big, mass is really big, density not so much. If we talk about mean distance, we can still go out. Now we're going out to Neptune for distance from the sun. Talk about revolution. We're still talking about Neptune. How long is their year? Their day for rotation. Who's got the longest day? Looks like Venus. Eccentricity, how circular the orbits are. Who's got the roundest orbit? Remember, that's the one closest to zero. Looks like Venus. Who's got the least round? Looks definitely like Mercury. Diameter. The sun, of course, is the largest one. Who's got the biggest one besides that? Jupiter. Mass, again, sun's got the biggest one. Who's got the next? Sun or Jupiter, because it's very big. In fact, if Jupiter is about 3 times larger, it wouldn't be a planet, it'd be another star. It would be a star producing more heat. Producing a bunch of heat. Jupiter does produce more heat than it actually receives from the sun. One, because it's large enough to actually have all that friction and heat, and two, it's pretty far away from the sun. Density, we're the most dense. Although if you wanted to find gold, there's the next one. For being such a small planet, it's going to have some really dense materials. Okay, I think I'm going to call it quits there, and I'll talk about the minor members of the solar system next. Bye. 22 minutes.